Welcome to mathematics class on Eko Learners Support for WAEC and NECO candidates. Remember, in our last mathematics class, we've learned concept of bearing, and we've learned how to determine bearing of one point from another. So in this class, we are going to be looking at calculations under bearing. No, don't let that scare you. I know bearing is one of the topics that students probably dread in mathematics. But I, your mathematics teacher, Folarin Ademola, have brought it to you in a simple way today. So let's learn together.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
What are we expected to learn by the end of today's class? So we should be able to sketch any given bearing. We should be able to determine the distance and bearing of a point from another and solve problems involving bearings. So simple. So let's move on. Let's quickly brush through our knowledge of bearing, the measure of angle from one point to another in clockwise direction from the north. In clockwise direction from the north. Then what is distance? Our basic mathematics is just the measure of the length between 2 points. The measure of the length between 2 points. So the basic unit of distance is meters. They may express this in kilometers, centimeter, but the basic unit is meters. We may also express it in yards, feet, inch, but the basic one is meter. So that's where we probably do. Let's look at this. Town A and town B. The distance between them is 4 kilometers. But there is a bearing reading of town A from B and that of town B from A. This shows the bearing of town B from A. The bearing of town B from A. That is what this shows. And this shows the bearing of town A from B. The bearing of town A from B. So let's not misconcept that bearing of and from. We've dealt with that in our last class. So here we are just going to use that knowledge. Consider the figure below. Let's consider this figure below. Which of the options best suggests the bearing of this? Which of it best suggests? Okay, think about that. 90, 180, 270. So it's between 180 and 270, right? I've given you the clue. So let's see. Yes. Your guess is as right as mine. Option C. Because it's greater than 180 and it's less than 270. So that knowledge is what we now take into calculating any problems involving bearing. Remember in our last class, we've dealt with simple interpretation like this. Now, we are fully in business. Town P is on a bearing 315 from town Q, while town R is south of town P and west of town Q. If town R is 60 kilometers away from Q, how far is R from P? Let me remind us that to successfully sail the streets of bearing, we must come with two tools, which is our knowledge of sine rule and cosine rule, which we have discussed in one of our previous classes. The knowledge of sine rule and cosine rule must come with us into this journey. You still remember them? Yes. We are going to recall and make use of them here. Now let's interpret this. Town P is on a bearing 315 from Q. So our reference is Q. Let's, because of the nature of what we probably will have, let's make it something. If this is our town Q, you know, is from, so town Q is the starting point, where this is the north of it. So P is on a bearing 315. So bearing 315 now reads 90, 180, 270, 315 will probably be here, right? So this will give us the bearing of, this is the point P. Let's take note of that. That's the north part of the point P. So let's write 315 degrees. That's the bearing. While town R is south of town P. Town R is south of town P. So this is the south of town P. So that is where the location of it is. If town R, so the south of town P, let's bring it down. The south of town P, we do not really know where it must stay. So if town R is 60 kilometers away from Q, if it is 60 kilometers away from Q, that means they are trying to look at it, okay, is south of P and west of Q, west of Q. So this is the west of Q, this is the south of P. So this place is town R. So take note of that. 60 kilometers. So the question is, how far is R from P? How far is R from P? So we are looking at this distance. Let's just call this distance X. Sorry, we have to use X. You can use any letter. So this has given us the picture of right angle, right? So the angle here is 90 degrees. That is settled. We know this. Now we need to understand this. Remember, if it has been like this and it's coming this way, this is 270. So this angle here, let's call it angle theta, is the first thing we need to solve. To determine angle theta, our angle theta will be 315. We are going to subtract 270 from it. 270. Because 270 is what spans from here down to this place. So the remaining part is what we want to get. And that is, when you subtract 270 from that, that is 270 from 300, that is 30. Then we have 15 to add to it. That is 45 degrees. 45 degrees. So angle theta is 45 degrees. That's settled, even though that's not where we are going yet. But it's part of what will make our journey smooth. How far is R? Now that we know this to be 45. So interestingly, our trig ratio is what we are first going to be tested on here. We know this angle now. So we are looking for the opposite and we have the adjacent. Then this will take us back to one of our classes that we've had a few time back, where we discussed trigonometric ratios, our SOHCAHTOA. Now we have opposite and adjacent. So which of these trigonometric ratios is suitable for this problem? Think about it. SOHCAHTOA. And we have opposite and adjacent. Good. Tan, tangent. So tan theta. So using our SOHCAHTOA, we can say tan theta equals opposite over adjacent, which we can then express it as saying tan 45 degrees equals opposite. The opposite is x and the adjacent is 60. So if we have this, you cross multiply. That's our usual statement. But let's learn to move away from that as senior students that we have, we multiply both sides by 60 degrees. I mean 60 by 60 centimeters or 60 kilometers as it is given here. So when you multiply both sides by 60, when you multiply this by 60, 60 will cancel out so that you can bring the 60 here. That means 60 multiplied by tan 45 degrees equals x. This tan 45 degree is a special angle, right? Do we still remember? All right. If you still remember, what do you think it is? 1, okay. 1 over root 3, okay. No, we are getting it confused. So it's a constant value that we should know. 1. So let's confirm that. 60 multiplied by tan 65. You can use our calculator or 4-figure table. I have mine here. Just to confirm it, tan 45 give us 1. Great. So 60 multiplied by 1 equals x. Therefore, x equals 60 kilometers. We then say, hence, or therefore, distance of R from P is 60 kilometers. Very good. So now we've been able to do justice to this problem. Determine distance under bearing concept. So let's look at another question, which is question number 2. Ayo travels a distance of 24 kilometers from X on a bearing of 060 degree. That is 3-figure bearing to Y. It then travels a distance of 18 kilometers to a point Z on a bearing of 125 degrees. Draw a sketch of the illustration. What is the distance of Z from X? Calculate the bearing of X from Z. So let's move into action with that. Ayo travels a distance of 24 kilometers from X, which is a starting point, on a bearing of 60 degrees. So if this is X, this is point X, and this is the north part of it. If Ayo travels 60 degrees, so to a point here, which is point Y, that means this place is our 60 degrees, and is 24 kilometers, 24 kilometers. That's the distance. This is the bearing. And this place is our Y. It then travels a distance of 18 kilometers from 18 kilometers to point Z on a bearing 125. We are not starting the bearing from X again. Rather, it will be from Y because he has gotten to this point. So before taking another reading, 125 degrees. And remember, this is the north, takes 125 around there, 18. So if it takes 125, that's 18. Right? So if we look at that, this is the point where we call point Z. The bearing is 125 degrees. So this joins with Y now. So maybe I should try and enlarge this so that we can have clear picture of it. If this is X, it goes 60 degrees. 60 degrees to Y. This is our 60 degrees. This is X. Our Y is here. And on Y, we have movement of 125. Which is this. So from here down, don't mind me. So maybe I should start from here. Good. So now this is 125 degrees. Remember, this is 24 kilometers. 24 kilometers. This is 18 kilometers. So the question is, what is the distance Z from X? Let's just make it Y, small letter y, that's the distance. And we are also interested in determining the bearing of X from Z. Bearing of X from Z. By bearing of X from Z, we are looking at from Z. So this is our concern for the bearing. This is our concern for the angle. So I want to believe that you sketch this. This is just a rough sketch, and this is very close to what we need. So now let's move on to solving the problem. We are done with question 1. The 2 is that what is the distance of Z from X? The distance of Z from X. Let's now think about this. This is 60. Remember, we've said it that the alternate part of if this is 60, that means this place is 60. Take note of that, alternate angles. If this is 125, what is left for 125 to complete 180? That is what this place will be. So take 125 from 180, we are left with, take 25 from 80, that's 55 degrees. So we can say from this angle X, Y, Z will be equals to 60 degrees plus 50 degrees, which is not 50 degrees, sorry, 55 degrees. 55 degrees, 55 degrees. Because 125 plus 55 should give us 180. So 55 degrees. Let's take note of that. 55 degrees. Let me write. Good. 55 degrees, 55 degrees. So if we add this together, that's 115 degrees. Now this angle is 115 degrees. Now that is known, we have the angle, but we don't know the side. And we know the two sides in which the angle is located in between them. We now have to look back to our understanding of trigonometry. Remember, in one of our previous classes, we've dealt with sine and cosine rule. The cosine rule says when we are given two sides and the angle between them, we can use it to find the third side. And that's the situation we are here. We are given two sides and the angle between them. So we need to get a third side. We make use of our cosine rule. Cosine rule. So remember your cosine rule that says for this problem now is going to be y squared equals x squared plus z squared minus 2xz cos of the angle of y. You remember? Good. So let's take a look at it. Let me just slash this so that we don't misinterpret it. We are looking for the y now. So y squared. What is our x? X is the side that faces the angle x. That's our 18 squared plus the z, that's 24 squared, the side that faces angle z. 24 squared minus 2, open bracket, x18 multiplied by 24 multiplied by cos 115. Interesting. So we take it further. Square of 18. We now have to make use of our calculator here so that we have to be sure of what we are doing. Let's do that together. I have my calculator here. 18 squared. That's 18 squared. Gives me 324. 324 plus 24 squared. 24 squared. That's 576 minus, we then use 2 to multiply this. We can just say 2 multiplied by 18 multiplied by 24. That gives us 864. Now, there is one thing we must learn here. Cos 115. Many students will slot that into the calculator directly. No problem. But there is knowledge that WAEC wants to test. How we can read our quadrants, angles within quadrants. So this one now, because it's 115, is going to fall under second quadrant, where cos is negative. So because it's going to fall under second quadrant, where cos is negative, we take minus cos. Now, at the second quadrant, what will angle 115 turns to? Angle 115 turns to something. At the second quadrant, remember, you are going to take 115 from 180 at the second quadrant. What am I saying? At the second quadrant, your cos alpha equals negative cos 180 minus alpha. So if you are giving cos 115, is going to be negative, open bracket, 180 minus 115. Please, if you are using this, it's advisable that you use that instead of slotting it down into calculator, because WAEC and NECO often put mark in that part. They are testing knowledge in that part. So this one now, changing this 115, subtract it from 180. What do we have left? We have it as 65 degrees. 65 degrees. We are going to confirm that together. So let's then add. Another thing we must not make mistake. Look at this negative. Is binded with this. This 864 is binded with this value here using multiplication. So don't treat it alongside this. Let's just add this and this. So which will give us 324 plus 576, giving us 900, right? 900. Then this one works by multiplication. Minus times minus plus, then 864 multiplied by cos of 65. Cos 65, which is 0.4226. So be sure, let's look at it. Is it the same thing as cos 115? Yes, only the sign, and that is what has happened here. Now that we have it this way, it becomes 900 plus, we multiply this, whatever answer that we've gotten here, multiply it by 864, that gives us 365.14. Let's keep it that way. Add this together. So we are going to have 1265.14. Remember, that is our y squared. Y squared. And we need y itself. So you take square roots of both sides. The square root of this place will cancel out the square here. And you take the square root of this, which is 1265.14. So what would that give us? Square root of 1265.14. That's our y. Y is equals to 35.56 kilometers. So we are not asked to approximate, no problem. So we will now give our statement that distance of Z from x. Remember, distance of z from x, which we have labeled as y, is 35.56 kilometers. So we are done with that. The next thing is calculate the bearing of x from z. Bearing of x from z, which we have marked out here. I want to believe that you have sketched this in your book and you have marked it out, so we know where we are going. To be able to do that, let's quickly look at things that are like pointer for us. We already know that from here to here is 180. 180. So we will need this angle to add to it. Or we take it in another way. If this is 55, automatically this place is 55 degrees. 55 degrees, right? So 55 degrees plus this angle, we subtract it from 360. It will give us the bearing of x from z. This analysis, we have to be careful of it. That is exactly what WAEC and NECO are testing us on. Alternate angle makes us to have 55 here. When we add 55 to whatever angle that is here, we now subtract it from 360, and that gives us the bearing of this. So since we have this, I want to believe that you put this down already. So I would love to clean this part so that we can do the last side there. So while you are doing that, begin to think around it, how well we can approach it and still get what we need. Told us. So looking at that now, we already have one complete family. I like to call it one complete family. The angle and the opposite side is known already. Once you have one complete family and you have any member of another family in a non-right angle triangle, what you use is sine rule. In a non-right angle triangle, you have the angle and the side facing it, and you have either side or angle for another family. We use sine rule. I call them family. Mother is the angle, daughter is the side facing it. So we have mother and we have the daughter. Here we are looking for the mother, whereas we have the daughter. We use sine rule. So using sine rule, our sine rule that follows here will be y over sine y equals z over sine z. That's the formula for the sine rule, remember? So we are interested in finding the angle z. Let's make that angle the subject of the formula. That will be sine z will be equals to small z, that is the side z, multiplied by y, z multiplied by sine y over this side. So let's substitute. Our small z is 24. 24 multiplied by sine y, which is 115 degrees, divided by divided by the value of y that we have here. The value of y, thank God, let me keep the value somewhere so that we don't forget. Y is equals to 35.56 kilometers. So to make our work easier, divide through, no problem, you can do that ahead of us, 35.56. So in doing this, it's going to be 24 multiplied by sine of this, sine 115 gives us 0.9063 divided by 35.56. So since you have your calculator with you, I want you to do that outrightly. Yes, let's not waste time. That will give us sine 115, which we have gotten here, multiply it by 24, divide it by 35.56. So all together here, we have 0.6116. Remember, that's our sign Z. We are interested in the angle Z itself. So we take the sine inverse of this. So Z is equals to sine inverse of 0.6116. 0.6116. Sine inverse 0.6116 is what we are looking for. So Z will be, on your scientific calculator, you just press shift your sine inverse. Whatever you have gotten, that is shift sine, will give you sine inverse on your calculator. 0.6116, you have it to be 37.7 degrees. Now that we've gotten that, we can then come back to say this bearing, remember we sketch out where we need, so it's not going to be difficult putting it in because we already have idea of where we are going. This is our concern. We have gotten this. Now our concern, the bearing of x from z will now be equals to, the bearing of x from z will be equals to 360 minus, we had this 55 with the value of z that we have gotten. So minus 55 plus 37.7. So let's do that together. That will be 360 degrees minus, so this one, are we together? So let's say 55 plus 37.7. That gives us 92.7. When you subtract this from 360, you have 267.3. Hence, we can conclude that the bearing of x from z, the bearing of x from z, that is this one that we've marked, is 267.3 degrees. Probably you can approximate to be 267. You find that interesting, fantastic, and that is bearing for you. So we have successfully interpreted this and solved this problem. You know, it's a comprehensive one, so I will leave you with another comprehensive practice question. Here, I would like you to do this on your own. Now, for your response, your answer, your question, your contribution, I want you to make use of our social media handles being displayed on your TV screen. Till we come your way next time, math is fun.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.